So here we are on the brink of learning a little bit about these PLRs, PLCs, kind of similar in nature. And really, the first thing we should do anytime we're going to grab some new piece of technology, uh, something new to play with, is to hop on and take a look at the instruction manual. I know, sometimes it's easier to just grab that piece of paper and throw it away. But with something like this, I'd highly recommend taking a look at the instruction manual. Okay, so here we are, TECO-SG2 Smart PLC User Manual. There it is. Okay, this thing is like a bazillion pages. Okay, and first and foremost, I'm not gonna try to go through the whole thing. But I would recommend that if this is something you're interested in playing with, you want to pick one of these up and test out some of its features, play with it a little bit, learn a little bit about the programming, that you would pick up this manual and at least take a browse through it to see how some of the things work, because there is a lot of features that can be a little bit convoluted as you're going through them. Okay, so like I said, it's about a mazillion, 161 pages long. We're not going to look through all those. I just wanted to show you a little bit about some of the basic stuff and the one we're playing with tonight. Okay, so I'm going to scroll down. We've got some general information, a little bit about some of the basic programming, things of that nature. We go in a little bit further. We're still scrolling through a wall of text, a little bit about the mounting instructions, and realistically, what I wanted to touch on just briefly is what we're dealing with, and then we'll hop over to the lab board and show this to you. So we are playing with the 24 volt unit. Okay, so in this one in particular, and this is going to depend on the model and the application, right? If you're using one of the 120 volt units, it's going to be similar but a little bit different. Okay, but for this one in particular, we are looking at positive input switching. Okay, so I'm going to be running a line from the positive off of my power supply, and I will run that through whatever switching mechanisms I have. In the case of our lab here tonight, we have normally open push buttons. They're all normally open. I do have one maintained button, but for the most part, they are 3 normally open momentary push buttons. Okay, so I'm going to be running a positive out to one side of those, and then off the other side of the momentary button, I'll be bringing that back to one of my inputs on the top of the PLR. So they will be I1 through 3, I believe, for my normally open push buttons, and then I have my maintained contact 3-position switch with the center off, hooked to I4 and I5. Okay, but for the most part, normally open, and I'm using positive switching. You're always going to want to check that. Per manufacturer, it could be a little bit different. Okay, so that's what we're doing there. But anyway, there's the manual. It is long. It does have a lot of great information inside of it. If you wanted to dig in and learn how some of your different functions work, what all the wall of text means inside of each of those functions, as you'll see here when we hop into the software, there it is. Okay, so you're going to get some great information inside of there. Let's take a quick overview on the lab board. Let's check this thing out. Let's see what's going on. So all we did when I put this together this weekend, I just ran 120 volts into the breaker. Full disclosure, it is on the same circuit as my computer. So if we have some kind of catastrophe happen in the eventuality that I blow this breaker, I'll be right back. But I don't think that's going to happen. Regardless, it could. So I don't recommend doing that either. But I just ran 120 volts just right off of an appliance tail into that breaker, and I'm feeding that into line and neutral of our power supply. Remember from the beginning of our lecture, most of these PLRs, PLCs are going to have some form of power supply, unless of course you're running a 120 volt one. This is just a 120 volt to 24 volt DC power supply. Okay, and then up there on the top side of the power supply, I've just run my jumpers to the different sections of the PLR. So I have my input power coming into the PLR here. It's also jumped into the expansion board, which we're not going to be using tonight. We'll use that next week in our lecture when we're talking a little bit more about programming and getting a little more in depth. Also, when we're discussing some of the variable frequency drive stuff, we'll use the expansion board a little bit in that section. Okay, that's just brought out to a set of highly sophisticated 5-port ideal lever lock Wagos, because that's what I had sitting around in here. And then I'm feeding that positive power out to one side of my switching mechanisms, which are just going to be these normally open push buttons. I've got green, red, and yellow. High end, very crazy. And then I've got that 3-position switch I was telling you about there. Center off, and then it's going to be a maintained contact to either side. We're not going to be using that tonight, but we might use that in the future. Okay, down below that, we've got a couple pilot lights. These are just 24-volt pilot lights. Those pilot lights are going to be run off of our coils, or our Q coils, as they are listed in the side of the software. So those just have a positive jumper ran down, and it is just daisy-chained through the common side of each of those electromechanical relays that's built into the PLR. Important to note, now, since I am using 24-volt, everything is 24 volts, so I've just daisy chained the whole line, but that doesn't mean we're restricted to 24 volts for these electromechanical relays. I could easily put a common of 120 volts in and then use the switch side of it to energize a 120 volt load, as long as I'm not going past that 8 amp resistive load that I'm allowed for this electromechanical relay. And you can see that in the literature, or it's also listed up here under the control port. But for our uses tonight, everything's just going to be 24 volts, and the only outputs I have on here are going to be those 3 pilot lights. Okay. For future lectures, I also have a potentiometer on here. We'll learn a little bit more about that as we get into the variable frequency drive section. But again, for tonight, we're not going to be playing with it too much. We're just going to go through some basic functionality. As for the switching mechanisms, as I stated earlier, I just ran a positive out, and it's hitting one side of each of the normally open buttons, and then those are all ran back to the inputs up at the top. Okay, so that's going to be your I5 through, or I1 through I6. Let me see if I can zoom in here a little bit. Maybe you can see. Okay, I1 through I6 at the top of the board, if the camera chooses to focus, it kind of does what it wants to, are just going to be our inputs from our push buttons. Okay, so nothing too crazy going on here on the board. Okay, pretty standard setup. Let's see if we can get a nice view there. Let's get that going. Cool. As well as on the top, I have hooked up a communication port. Okay, so communication port just comes with a little cover on it. You pop that off, and you pop on your communication cable. They sell these in USB or a serial connection. Obviously, USB is the most popular these days. But once we've plugged that in, we gain the ability to link this over to the software on the computer, so we can read and write programs off of it and also monitor the PLR remotely. So we'll play with that a little bit as well. Sound good? Let's hop over in the software and take a look. Let's hop over in the software and take a look. Maybe we should turn it on. All right. Let's fire it up. Let's fire it up. Let's turn that off. So right there on that main screen, as we saw in our lecture from Big Bad Tech, we can just see what is currently actuated on the PLC. They'll be highlighted in dark when they are actuated. I don't think I have a program in here currently, but I might. But you can see when I push down push buttons. So I'm just going through and pushing push buttons right now. I know you can't see that, but you can see what's happening on the screen. Okay. So you do have that ability. It's not very high tech, and it only matters to a degree for our purposes tonight. And it is in stop mode, which is fantastic. Let me go up a little bit on that. Oh, that looks pretty good. That looks nice. I think we got a good view for it from that angle there. So what I'm going to do is I'm going to fire up the SG2 software. Now, just so you know, this looks a little funny on my screen. I have ultra-wide monitor, so this program does not like to be resized very much. So I apologize in advance for how this might look on your side. Hopefully you can see everything okay. It looks like it's laid out all right, so you should be able to see everything. But what we have over on the right portion of the screen is going to be our programming ladder logic area. Okay, along the bottom of the screen, we have a number of inputs, outputs, different functions and features, and we'll go through those a little bit at a time. Okay, and then along the top of the screen, we have some different things. We can run, stop, we can quit, we can view this in a different mode. We can see the keypad and the actual face of the PLR. I'm not going to do that in here because it doesn't cooperate well with my monitor. Maybe towards the end of the class, we'll take a look and see what's going on. We have some different options up at the top, and what we're really going to look into is operation, and we're going to go to link COM port. Okay, so when we link COM port, we are establishing a link to the PLR. And this is what we're going to use for programming and for viewing what's going on remotely. So I'm going to go ahead and link. I happen to know it's on COM port 8. You might need a little bit of computer savviness or just jump through the comms until you find your PLR. But once you do get connected to it, it will say connect successfully. And we are now linked over to the PLR. Okay. From here, we can write a basic program. And perhaps we should start with something simple. Okay, so remember from the lecture that this PLR, and pretty much any PLC or PLR you're going to use, is going to use either a make or break contact to energize some form of coil. The coils are the outputs. Those contacts could be inputs, right? They might be some field wireable input like my buttons or a sensor, or they could be some kind of internal input. And we'll show you a little bit about that as we go through. So what I'm going to do just to get the ball rolling is I'm going to put some inputs in. So down in the bottom left corner, I'm going to grab that input. I'm just going to click that and I'm going to drop one in. I'm going to get this pop-up window and it's going to ask me what exactly I'm putting in. Now we do have the option for a make or break. It's going to call it STR or STR not. Okay, the one that looks similar to a normally open contact is going to be our make instruction, and the one that looks like a normally closed contact will be our break instruction. Now remember, just because all of my buttons are normally open doesn't mean that I can't program them to act like a normally closed contact. Okay, we'll show you that. So let's start with something simple. Let's take input 1. I happen to know that's the green push button, or at least I'm pretty sure it is. I probably should have wrote it down in advance, but I didn't. So whatever, we'll figure it out. Okay, I'm going to drop that into the first field inside of my ladder diagram. Now, another thing that's important to note is, as we saw in our video earlier, we basically have 4 contacts here. 1, 2, 3, and 4. The first 3 will be some form of contact or a continuation of a contact point, and the last section will be for our output. Okay, so since I just want to push my green button and get hopefully a green light, I'm going to take this line tool, it's under A down here in the bottom, and I'm just going to create a couple lines over to that final section where I can put in my output coil. Okay. So I am going to go down to the bottom and I am going to grab an output. I'm going to click that button and I'm going to drop it into the last section of our line diagram. It's going to pop up my little window again, and it's going to ask me to select the coil and what exactly I want it to do. I'm going to leave most of these basic for now. Next week we'll dive a little deeper into what some of these different functions and sections might do, but for all intents and purposes I'm going to leave these at default settings for tonight. So I'm going to select output coil Q01 and I'm going to drop that into the program. So now when IO1 gets made, okay, when it logically receives a true or a high, it will hopefully turn on that green light. Okay, so I've entered this incredibly complex program in, and then up at the top of the screen I'm going to write this over to the PLR. You have a write button up there and it's just going to warn me that the old data is going to be lost. I don't really care. So I'm going to hit yes. You can't see the screen, but I got green bars going up and it's going to tell me that the write is okay. We have successfully written this incredibly complex program over to our PLR. So let's take a look at that. Now remotely, I can run this remotely. I can go ahead and start it remotely, but let's just show you how that looks like if I were to start it on the screen. Okay, again, the ridiculously small screen, I don't ever recommend using it unless you really have to. But in this case, let's at least show you what it looks like. I can hit escape to get into my menu. I'm just going to go down to run, and I'm going to hit OK. It's going to bring me up a dialog that asks me if I want to confirm that, and I'm going to say yes. Okay, from here, I can escape back out, and in that bottom left corner, it's going to let me know that it is running. So our incredibly complex program is currently running. Now, if we did this right, this normally open push button should energize our green light. Okay, so while we push down and hold our button, we get the green light going. Ooh. Ah. We will bask in the glory of our accomplishments as we have turned on a green light. Okay, very fancy, very high tech. Let's jump back over though and see if we can do some more fun stuff. Okay, so back over inside of our program, I'm going to go ahead and stop it. I can stop the device remotely, and I'm going to go ahead and do that so we can try something else. Okay, so now that we have created that amazing scenario with that normally open momentary push button, let's make a little change to show you how logic works inside of these systems. Okay, so I'm going to double click that IO1 button, and I'm going to change that to a break instruction. Okay, when I change that to a break instruction, I want to make sure I'm on IO1 still, and I can confirm it by that lowercase I right there inside of the input. When I change that to a break instruction, it's going to make this normally open push button act more like a normally closed push button, right? It's going to have the same effects as a normally closed push button. Let's see what that looks like. I'm going to write it over to the PLR again, give it a second to send it. It's warning me that the old data is going to be lost and all that jazz. I'm going to wait for it to write over. It's going to say okay. This time I'm going to run this remotely. I'm going to show you what this looks like real quick. I don't really want to read the program from the module. I don't need to do that right now. But as you can see on the screen, what it's showing me is that IO1, since I've set it up as a break instruction, is acting as normally closed. So we have current flow through to Q01, and Q01 is energized. Okay. Now you can play with some of these tools on here and force it to work inside of a simulated environment, which is something you're going to want to do if you're not directly connected. But they don't work too well while it's live. So let's just jump over and look at it since we've got it over and up right now. I'm going to jump right over, and now my normally closed or my normally open push button is acting like a normally closed push button. Okay, so we have that green light on, and when I actuate the push button, I'm going to turn the light off. Okay, simple, elegant. Okay, so I don't need to go out and buy a bunch of contact sets that are going to be of different natures, normally closed, normally open. Now, I can program a normally closed button to work in the same nature. I just have to reverse the operation of those make or break instructions that have been logically instantiated in the program. Okay, but that's wow, fancy. Now we can turn the light off. We're really getting somewhere. Okay, let's jump back over into our program. Let's dig a little deeper. Okay, so that's probably our first rule, and something that's going to be important that we kind of learn in advance is that these do work a little bit different, and we can make changes based on whatever parameters we want to instill in the program. So let's go ahead and stop that. Let's clear this out, and let's try something else. So something that you spent a lot of time with probably, and hopefully you got a good grasp of, is a memory circuit in third year. Everybody remember how a memory circuit works? Okay, we basically have a holding contact that we have in parallel with a start button that's normally open. And when we push down that start button, we are establishing a memory circuit through some kind of relay or auxiliary coil on the motor starter or relay. Okay, we use these pretty often. Now, when we want to build this inside of our PLR, it's very similar, and it can work in the same kind of ways. So what I'm going to do is let's create a basic memory circuit. So I'm going to go down, I'm going to grab an input, and I'm going to drop it in. Now, if we remember how these worked, typically that memory circuit is going to start with a normally closed stop button. Okay, so I happen to know, or at least I'm pretty sure, IO3 is the red button on my PLR. Now, it is normally open from an electromechanical state, but I want it to act like a normally closed push button. Okay, so I'm going to set it to a break instruction for IO3 to start this. Okay, so that will be my stop button. Now after that, I'm going to need my normally open start button. So let's use green in here, and we knew green was IO1. It seemed to work right before, and hopefully it's still consistent. Sorry, I needed a drink of water. So I'm going to drop in IO1 as a normally open or a make instruction. And I'm going to say these terms somewhat interchangeably at first, and then I'm going to switch to just saying make because it makes a lot more sense when we're dealing with this. After that, I'm going to go out and I am going to energize my output coil Q01. That's that green light. Okay, so I just dropped a Q in there, Q01 at the end. Okay, so now we have established a start-stop circuit, but we haven't inserted our memory yet. Okay, so what we need to do to get that memory in is take a couple horizontal lines or vertical lines on L, and we're going to drop that in so that way we can put an auxiliary contact in parallel with our start button. Since I'm using Q01 at the end, I can use a virtual contact. So I will drop in a Q coil here. I will make sure that it's set on Q01 and that it is a make instruction. So what we have here is we have basically just created a virtual auxiliary that we are going to use for our memory circuit. Let's write this over. Let's take a look at that. Give it a second to beam it up. Cool. Looks good. Now we can run remotely again. Okay, I don't really want to read the program from the module. It's unnecessary. I'm going to leave the programming software up for a second so you can see it inside of the programming software, and then we'll jump over to the lab board. As we can see here, IO1 is our green, normally open push button. Q01 is going to be that virtual contact or that virtual auxiliary off of our emulated motor starter. Okay, and Q01, the actual coil portion, will just be that green light or our virtual motor starter. Okay, so we see what it looks like. Let's take a look at what happens when I push the button, and then I'll jump over and show you. When I push the button, IO1, it kind of skips. You're not able to see it because it happens so fast. But what happened is IO1, I actuated the push button, and then we established that memory circuit down through that virtual contact. Okay, let's see what it looks like on the lab board. I'm going to jump over. So we're over here on the lab board. Now we have our green start button, red stop button. Okay, when I push green, now we have held our light on. Okay, so we have created that basic start-stop station. Okay, very basic in nature, but one of the fundamental bases of motor control or any other scenario you might be using for a number of applications out in the field. Now, when we push stop, we are breaking that memory and it will shut off. Okay, so this is your start-stop station. Now, obviously, we could put a couple starts in parallel, a couple stops in parallel. We'll play with that a little bit more next week, kind of go through some of those ladder diagrams you were building in third year, and just make sure that we can keep it going. But there is your basic start-stop station. Okay, cool, exciting. Let's jump back over into the program. But what if we wanted to do something else? What else can this thing do? Cool, we made a start-stop station. Well, we can do a lot of other really cool stuff. Okay, so why don't we make some kind of timing function? You're fine, Robert, no worries. Let's add a timing function to this. Okay, so I'm going to go in and I'm going to grab a timer down here at the bottom. Okay, maybe what we want to do, and let's build towards a goal. Perhaps we want to give users in the area a warning that our motor is about to start. So we need to have a yellow flashing light indicating that our motor is about to go. Okay, so let's build that. and let's see what it looks like. So I'm going to grab a T down here at the bottom for timer, and I'm going to drop that in below Q01. Now when that pops up, you might have some Vietnam style flashbacks of those operational diagrams that you had in third year for some of your timing relays. Hopefully your teacher warned you that that wasn't going away, that was a thing, right? And it's still a thing in here. Okay, so I'm not going to go through all those. Hopefully you have a pretty good idea. If you need some reinforcement on the topic, please reach out and let me know. But what is basically going to happen with this one is we have that on delay timer. Okay, so after we get an enable command, okay, after it's energized, we're going to have a certain amount of time, and then we will have an output. That's an on delay. Okay, we remember that. We remember on delays. Let's go through. We have a couple other ones. So that's timer mode 1. Timer mode 2, we have a little bit different form of on delay. And a lot of these you can read up on in the manual as well. 3, we have that off delay timer. Oh my God, flashbacks, right? We have a different off delay timer in mode 4. And mode 5 is our flashing or alternating style relay, okay? So what we're going to have here is that on, off, on, off, on, off. That's what we want. We want to flash this a little bit. Give them a little pizzazz as we're going through. So let's drop a flash timer into our equation and see what that looks like. Now, much like those square D Jack 70s or whatever you were looking at last year, we do have a time base. So I'm going to set that time base to 0.1 seconds, and then I can set a value inside my preset section here. Let's set it to 0.3, so we'll get maybe a somewhat rapid flash. Okay. So I'm going to say OK on that. Looks good. Set as timer 01 in flash mode, 0.1 second, and I'm going to flash every 0.3 seconds. Sounds pretty good. Okay. So I'm going to drop that in. Now I have T01 at the end. But what I need to do is I need to connect that up to my Q01 coil. Okay. This isn't going to quite get us where we need to be, but I'm going to show you how to get there. Okay. Once I have that T01 coil set, I need to make it turn on something. I need to have those contacts for it to turn on. So I'm going to grab that T again, and I'm going to set a T timer here. Let's grab that T. Let's drop a T timer contact. It will be a make instruction. And now I need to tell it what I want that T01 to do. Let's make it flash the yellow light. So I'm going to go over and I'm going to drop a Q coil in that coil section at the end, and I'm going to go to Q03. I do believe that's my yellow light. Okay, so I want to flash my yellow light. Now, is this going to work properly? Not yet, but we'll get there. We'll get there. Let's take a look and see what that does. Currently, when I push that start button, looks like I'm going to turn on my green light. I'm going to turn on this timer, and I'm going to be flashing a yellow light. So I'll have a green light on and a yellow light flashing. It's not going to be very elegant, but we can use it to show you how to edit this program a little bit and add to it. Okay, so I'm going to write that over to the PLR. Give it a second to load. The longer the program, the longer it takes to send in, and then I'm going to run the program. I don't want to read it from the module. It doesn't really matter to me right now. And we can see inside of here. Did you hear my Steam notifications? That's funny. Shh. Shh. All right, so we are jumping over. You got me laughing. Don't start with that. All right, so we are jumping over to the lab board. Let's see what we've created here. So now when we push that green button, damn it. Okay, I knew this would happen, right? I kind of called it, right? We have that yellow light flashing. We got our green light on, but it doesn't do us much good if we have this yellow light flashing and the green light on at the same time, right? We need a pre-warning. So let's jump back in and see if we can fix that. Let's stop that. Oh, I messed it all up. Well, the beautiful thing about this PLR and our setup here is that we have an easy way of fixing this. Okay, so I'm going to stop that remotely. And here's, oh, that's a great question. That's a really great question. It's typically Esper, so I'll be running white, black, blue. But it varies. play way too much magic, so that's a topic for another time. All right, so here we are. We need to do a couple things to fix this. Okay, we really need to do a couple things to fix this. First of all, what I'm going to do is I'm going to show you the memory coils. Okay, because we don't necessarily want Q01 to come on at this portion of our operation because that's our green light. So we need to change that. So let's use a virtual internal relay. So I'm going to grab the M down at the bottom, and if you can see when I highlight it, it's an internal memory relay. And I'm actually going to replace this Q with M01, and I'm going to replace our memory contact with an M01, still a make instruction. So now what we've done is we have integrated a virtual relay into the system. Okay, we still need to turn on that green light, and I'm going to show you how we're going to accomplish that. We need to insert some more stuff into our top lines of code, so I'm going to go down to this insert button, and I'm just going to click here so I can insert another line in there. Now what I'm going to need is another timer, right? I need a timer, one to flash the light, because that's our flash timer, and then I'm going to need an on delay timer in order to turn our motor on after a specified amount of time. So let's go in, set a timer. I'm going to need to pick a different designation, so let's go with timer 02, and I'm going to do an on delay timer mode 1. I'm going to set the base time on here to 1 second, and then let's give it a certain amount of time before we start. So I'm going to do 6 seconds. Okay, 6 seconds. Let's drop that in. TO2, 6 seconds. Let's connect it to that top line up there. Now TO2 needs to do something. TO2, that on delay timer, is what's actually going to start our motor. So we need another contact in here to start our motor. So I'm going to go in. I'm going to select TO2 because I want the on delay timer to start the motor. I'm going to drop that contact in for TO2, and I'm going to take that over to Q01, which is our green light. Didn't click very effectively. Let me see if I can click a little bit more effectively. There we go. I'm going to do Q01, and I'm going to drop that in. Now, if we think about this logically, we're still going to have one minor problem with this scenario. And that minor problem we're going to have is that that flashing light is still going to be flashing, right? Once it's logically connected and it's receiving that true, it will just keep flashing and flashing and flashing even though our motor's on. We don't necessarily want that. Once the motor's started, this should already hit the proverbial fan. So we need the yellow light to just go off because it's just going to get annoying and the operators might be exposed to seizure conditions. So what I'm going to do to stop that flashing is I'm going to come in, I'm going to grab my T, and I'm going to set a break timer on TO2. So that way when TO2 gets energized, it will flip to the opposite state and it will stop the flashing. Ooh, yeah, it will. Watch. Let's figure it out. TO2, beautiful. Beautiful. So TO2 is breaking it. So let's go through this logically. We've got our normally closed stop button on IO3. We've got our normally open start button on IO1. We've got memory that's been built in here. Okay, so the memory is just going to be a virtual relay, okay, that is acting as our holding circuit. Now what that holding circuit's going to keep going is TO1. That's our flash, our yellow flashing light. It's also going to hold TO2. That's our on delay timer. That's going to start our motor in 6 seconds. Okay. Next line of code, we've got TO1. That's our flasher. And it's going to flash Q03 for as long as it can. But after 6 seconds, TO2 will close. TO2 here will open, so that will stop the flashing, and it should, if we did it right, energize our green light. So let's send that over and see how we did. Let's beam me up. Beam me up. All right, we wrote okay. Let's give it the run command. I don't want to read the program from the module. We can see it right there on the screen, but it doesn't like to run very well if I'm not actually showing it to you. So let's jump over and show it to you on the lab. So if we did everything right, and I think we we might have. We're about to find out. When I push that green button, we should get our yellow light flashing for about 6 seconds, and then we should get a solid green light. The yellow light should go off. So let's try it. Let's see how we did. Okay, so we got our warning sequence that the motor is going to energize, and then after a given amount of time, our motor starts. Okay, motor boots up. So what we've created here, in a little bit of time, a little bit of tinkering, is a somewhat complex, I think you could agree, if we were wiring this with electromechanical relays. Kind of a nightmare, right? 2 timing relays. We have basically an auxiliary relay. We had a motor starter and some pilot lights kind of situation. But with use of the PLR and the programming software, we were able to create this relatively quickly. Okay, so this skill, very valuable, and I highly recommend picking up the software, playing with it. You can virtually test a lot of these things. Okay, yeah, and that's, you know, so much easier than third year, right? I mean, you have to have that foundational basis of electrical and mechanical relays to really understand and appreciate where we're going and the direction that we're moving in with this kind of equipment. Because if you didn't understand what a pain those were, and if you never had to wire a group of them, you wouldn't know how much work goes into it. And for this, it's a lot simpler. I wire my inputs back, I wire my outputs, and then I take care of everything else within the software. Okay, so kind of a beautiful thing. So let's stop it and kill that. Let's jump back over into the programming software for a second. Let me show you a couple more things. Oh, the light box. Well, I made that, so I can give you a link to all the crap I bought. Like I buy, let's show you. I buy these push buttons at Amazon, right? Like these are Amazon push buttons. They are, I probably got 5 normally open push buttons for like $10. The pilot lights, again, probably like 5. I think I got 10 for like $12. Okay, the enclosure, Amazon. I think I paid $10. Okay, so switching mechanisms, all that, very cheap. The PLR, this is a bigger one. This one's probably about $150, $160. The little one, probably like $120. Okay, maybe $100, depending. Okay, and there's different options out there. Obviously, this is the TECO, but you could get the Eaton. Allen Bradley makes one. A ton of different manufacturers. Siemens makes them too. So there's a bunch of different ones. Power supplies, probably $30, $40. I mean, this whole setup right here on the board, probably $200. Maybe a little less if you have access to some of it from your shop. And then you got to build it yourself. The time is the thing, right? But to me, that's kind of fun. I don't mind doing it. Let me show you a couple more functions. We are closing in on our time together, so let me show you a couple quick functions. Let me right-click so I can select everything. I'm just going to delete it. Let's show you a couple other quick functions, and then we will get you on our way. And I'll show you how to complete some of these next week. But let's show you the counter. Okay, counter, there's several situations where you might want to use a counter. Maybe you need to actuate some kind of packing device after running so many things down a conveyor belt. Any number of things. Parking garage, maybe it lets so many cars in before it says we're full. Okay, who knows? Any number of situations. So I'm going to put CO1, actually, I need a better one than that. I need an input. Let's do an input. Let's do IO1. IO1, so I have a push button to hit. And then we'll go down to the end and we will put a counter coil at the end. Now, there is a bunch of different counting functions in here. I will show you how to actuate the reset next week. But in the interest of time, I'm going to make it relatively quick and just use this basic counter without overtaking, without power down, retain current value. It's fine. I'm going to set a preset value on this to 5. So after 5 counts, I should get some kind of actuation. And then it's going to set my CO1 over there. Underneath it, I'm going to set a CO1 make instruction. So after 5 counts, I should get an actuation of that CO1 contact. And after that, let's put in a Q coil. Let's turn on that green light again. That green light's, it's putting in work today. Putting in work today. Let's write that over. Old data is going to be lost. That's okay. I'm fine with that. We'll show you the counter function, then I'll show you one more function. We'll get you out. So this is the counter function. man, it's not too easy to see on the screen, so we'll send it over here. Read program over. Let's jump over to lab board again. Let's test it out, see if we did good. So we are going 1, 2, 3, 4, 5, and we get our actuation. Now we could set a button to reset, and I will show you that next week. But since I didn't program it in, I don't want to get too deep into the rabbit hole. We can't turn it off. It's just on. It's just on forever now, so that's fine. And let me show you one last little feature. Now, we talked about the fact that trying to program these on the ridiculously small LED screen is a horrible idea. I don't recommend it unless you're in a pinch. But let me show you one thing we can do with that ridiculously small screen. I'm going to go in. I'm going to use my IO1 green push button again. I'm going to throw a normally open on there. Maybe I'll make this a whole, I'll tell you what, let's make this a whole motor starter type scenario. Let's throw this in. I'm going to do this one quick, IO3. I'm going to do that as a break instruction. I will take that over to IO1. That is a make instruction. Let's put some memory in there. Boop, boop. Put some memory in there. We'll jump that over to an output coil. But what output coil do I want to use this time? Let's try this. H says HMI/text display. I'm going to drop that in. And then inside of this, I am going to edit this. And inside of this dialog, I can write something in here like have a good, oh shit, didn't do the whole thing. Edit, have a good, let's start like in the middle, night. Oops, didn't do too good. Night. I can spell. IGHT. Have a good night. Exclamation point. Cool. Let's put that in there. Cool. So now we've got that awesome HMI text at the end, set to HO1. We'll dump that in there. Let's add some kind of holding circuit to that. So let's just put a memory one in there maybe. Let's go MO1. That's fine. Let's drop MO1 here as well as a holding circuit. Let's put that there. Yeah, I like that. Let's run that. Oh, I didn't load it. Hold on. That's not going to work too well if I don't write it. Let's beam it over. Beam me up, Scotty. Right, okay. Boom. Now let's run it. I don't want to read the program from the module. I am going to push that button. Oh, I got to bring you with me. Lab, I am going to push that button. Boom. I don't know if you can see it, but it says right there, you folks have a wonderful and a good night, okay? You folks have a wonderful good evening. That's all I got for you tonight. It has been a pleasure going through this with you. We're going to dig a little bit deeper next week. So if you enjoyed that, pick up the software. Give it a run, okay? We'll dig a little in next week. We'll go over converting some ladder logic diagrams to PLC logic. And if you got any questions, concerns, you want any more information, let me know, okay? And just don't hesitate to reach out. And as usual, it has been my sincere pleasure to get you through this section, and we will catch you all on the flip side. Don't forget homework 402. Be good out there, folks.